So hello students, welcome once again. Please, it's a request to please do like and share the video if that's helpful, and do subscribe the channel also. See, that's an interesting question of definite integration. I will say it's a question apart. I mean, it's a totally unique type of question with a unique approach. So that's the target of this series, that to give you as many different type of questions as possible. So let's start. So here we have to find, we are given actually this information, this relation, and we have to find our f of x here. How to start? So of course we have already discussed Leibniz rule of differentiation. So I'll be starting with Leibniz rule of differentiation, but before that I would like to see what's the problem, because here within this integral, of course we can see because of dt the variable of integral is t. Okay, but you have x also, which is the variable of this function f of x, or the equation or the relation, whatever you call it. Okay, so I will rewrite it as x plus 0 to 1 x into f of t minus t into f of t. I don't think anyone will disagree with that. It's a simple algebra. So moving ahead, see, the purpose here is you all will come to know, because see, as I said, the variable of integral is t. So what will we consider? X in that case. So for us within integration, x has to be a constant with respect to t. So I will take it out of the integral sign. This is one integral attached with the variable x here, minus and the integral 0 to 1 t times f of t dt, and it's a definite integral with fixed limit, constant limit. So now here I will call this to be a constant p, and I will call this to be a constant q. So for me in that case, our fx is x times 1 plus p minus q. So that's the f of x here. Now see, I will say integrating both the sides from 0 to 1. So integrating, of course, with respect to x, both the sides, and within the limit 0 to 1. So what do we get? So we get 0 to 1 f of x dx is equal to 1 plus p is a constant. It will appear outside the integration, and then integral x dx 0 to 1 minus q, again a constant, 0 to 1 dx. Now see, what have we replaced p for? We have replaced p for this integral 0 to 1 f of t dt, and we know from the property of integration, if the limits and the function of a definite integral are same, then by changing the variable nothing changes, the value remains same. So what does that mean? That simply means this is nothing but p. So p is equal to, now this is 1 plus p, integral of x is x square by 2, 0 to 1 minus qx 0 to 1. So how much is it? So you got a relation between p and q. So what is it? So it's 1 plus p by 2, isn't that, bacho? And minus q. So from here we can write, if I take p by 2 this side, so it will be p by 2 is equal to half minus q. So that gives us one relation, p is 1 minus 2q. That's relation 1. See, the target here is, since we have to get fx, we don't know. See, since till we know f of x, how can we integrate it? Okay, so the point is that to get p and q here. Now what for q? So for q I will say, first multiply this by x both the sides. So what do we get? X into f of x is equal to 1 plus p times x square minus qx, and now again integrating between 0 to 1 both the sides. So we get 0 to 1 x times f of x is equal to, again 1 plus p is a constant, we all know it, integral of x square with respect to x from 0 to 1 minus q is again a constant, integral of x with respect to x from 0 to 1 here. Now what? So again, how much is this? So we will go back and look for q. Q is what? 0 to 1 t times ft integral. So that's our q here. So q is equal to 1 by 3 1 plus p minus q by 2. Take it that side. So 3q by 2 is equal to 1 by 3 times 1 plus p. So that means 9q by 2 is equal to 1 plus p here. Now let's put the value of P here. So what was P? P was 1 minus 2Q. So it's 2 minus 2Q. So take it this side. 9Q by 2. That's fine. Yeah, I think so. Right. So take it this side. So it's 13Q by 2 is equal to 2. So Q is 4 by 13. If I am not wrong, just check it out once, bacho. We got 1 by 3 minus Q by 2. So, oh yeah, that was a, no, it's okay. We will take it that side. So it's 9Q by 2 is equal to 1 plus P, and P is 1 minus 2Q. Let me check it again. So 1 plus P will be 2 minus 2Q. Okay. When we take it that side, 4Q, 13Q by 2 is 2. Q is 4 by 13. It's all okay. So therefore, P is 1 minus 2Q. So 1 minus 8 by 13. So it's 5 by 13. So hence the function. So therefore our function is x times 1 plus P. So 1 plus 5 by 13 minus Q minus 4 by 13. So therefore it's a linear relation, a linear function, 18x by 13 minus 4 by 13. Again, as I always say, normally calculation part is not important, approach is important. Okay, so that's, I found it to be a very unique approach, bachon. That's why I decided to share this question with you. Once you know it, don't miss this approach. It might be really very helpful in such type of situation where I couldn't find any other way to get f of x actually. Okay, so I spent some time on it and kept on thinking. So it happens normally. See, what happens is that you are trying. So we are trying something, okay, and then started trying something else. Then all of a sudden I thought, okay, let's assume to be P and Q, because again and again I have to write these two integrals. So I randomly just assume, replace them with P and Q, and then all of a sudden it struck my mind that why not to try to get value of P and Q, and this is how it started. Okay, so that's it. So that was the question for today, bachcho.